Okay, so when we're given an equation that they tell us to find some sets and then graph it, starting with this equation, y equals negative 2x, they gave us a chart, and the chart said, what if x is 0, negative 3, and 3? So what we want to do is we want to plug in 0 for the x. And so over here, I plugged in 0 for the x. See where the x was next to the negative 2. So 0 times negative 2 is equal to y. And when I do the math, it says negative 2 times 0 is 0. So when x was 0 in the problem, in this case, y ended up being 0. And so that would be our first coordinate, 0, 0. Now we want to know what happens if x is negative 3 in that same problem. So if we plug in negative 3 for x, then we do the math, and it says y is 2 times negative 3 is negative 6. So we found out that when x is negative 3 in this problem, then y is negative 6. Now we want to plug in positive 3 for the x. And so we have y equals negative 2 times positive 3. Whoops, wait a minute. I can see I made a mistake. Up here, this was negative 2, and I missed it. Oh, gosh. So this is a positive 6. Oh, dear. Glad I caught that. Okay, so back down here, when x is a negative 3, y is a positive 6. So when x is a positive 3, when we do the math, that gives us negative 6. Okay. All right, so here's our coordinates. And so when x was a positive 3, y was a negative 6. So now what we need to do is we need to come over here to the graph, and we need to put those on here. We have 0, 0, and we have negative 3 and positive 6. And we have positive 3 and negative 6. And so here we have the line that can be drawn to connect all of those. I don't have a straight edge here to do that. Okay. Now, they gave us this chart, okay, and I told you a minute ago that they didn't have to give us that chart. We could have made our own chart. We could have said, what if x is 1? What if y is 4? What if y is negative 4? See, it didn't have to be just x's that we can put in this chart. It could be y's. And so what happens is if I use that same equation that said y equals negative 2x, if I put in there what if x is 1, let's try that. What if x is 1? Then y is negative 2. And so then we find out, well, when x is 1, y is negative 2. Let's do it. What if y is 4? So in that same equation, if y is 4, that means we're not plugging anything in for x this time. We're plugging it in for y. So we have negative 2x. Then we want to solve for x, because that's what we're trying to find out. So we'll divide by negative 2 to get x alone. So we ended up getting x is equal to 4 divided by negative 2, which is negative 2. So there's negative 2 there. And then what if y is a negative 4? Oops, negative 2x. Okay, so we're going to divide by negative 2 to get x alone. So that's going to give us a positive 2. So x is positive 2. So these sets, I want you to see something. What's going to happen here is even though we chose to use different numbers to solve this equation, notice when we put them on this graph, if we go 1 and negative 2, and then negative 2 and positive 4, and positive 2 and negative 4, notice that if we'd used those 3 dots instead, we would still have drawn the same exact line. So they're starting you off with a chart to use, but it's not a magical chart. It's just a chart where they've said, oh, what if, just find out what happens when you use these numbers. And because no matter what numbers we would have chosen, it still would have formed exactly the same line, because this equation of a line, this equation forms exactly this line no matter what numbers we would start with. The key is that we can't choose both numbers. And if we're going to do x and y here, we can only choose one and leave the other one blank. Choose one and leave the other one blank. And you can put any number you want to in all of infinity. It doesn't matter. You're going to come up with answers that you can graph.